All right, so basically what we've been doing is looking at functions as a family. So a C value allows that family to move up or down. It is what we call the vertical phase shift. So on your paper, you kind of have that blank graph, and basically what I did was in black represents the derivative or the antiderivative of cosine x dx, which we know to be as y equals sine x plus c, because derivative of sine is cosine. The plus c, because the derivative of a constant is 0. And basically, the 3 different graphs sketched out for you could represent the different values of c. So c could be plus 2, c could be minus 2, c could be 0, and that would be your graph in standard position. So the family of functions that we have created all look like this. What do you notice about the key points on all of these? Since the phase shift is just directly up and down, all of the maxes are at the same x value. All of the mins are at the same x value. The points of inflection, meaning where it changes from concave up to concave down, are also all at the same point. Now, granted, there's some human error since I sketched these, but what you should notice is that the slopes should be the same, the maximum and minimums are the same, the points of inflection are the same. The only thing that is changing is where the graph is located. So what the second half of 6.2 kind of talks about is, okay, how does that directly relate to what we were talking about over the past few days? How can I see this as what it is, which is a slope field? A derivative becomes a function. An antiderivative becomes a family of functions if that antiderivative is indefinite. So if it's an indefinite antiderivative, then it becomes this family of functions where we could find C, but in general don't know it. So these questions directly relate to the problem we just looked at. So it says, since cosine of x equals 0 at odd multiples of pi halves. So that should make sense, because that's pi halves, 3 pi halves, 5 pi halves, goes up and down from the top of the unit circle. We could see that the slope at all of those odd multiples will be 0. How can we tell this? Well, what do we know about the derivative of an extrema? It's 0. It's a critical point, and the derivatives at critical points are 0 or dne. So it says, how can you tell? Well, we have horizontal tangents at all of those odd intervals. Can you see that okay? Or do you want me to change the background? I keep forgetting that there was a time period where I had to make.
Well, if you change the background, we're not going to see the words.
Should I do black? Oh, that's pretty.
Oh, no, that looks ugly.
No, I like that.
That looks ugly.
No, it's pretty.
But you can you see it?
Yeah.
I do black.
Leave it. No, leave it.
You can't do black.
No,
You won't be able to
blue's
read.
too dark. I can't read it.
Do yellow.
Orange is pretty.
That's what I just did was orange.
No,
I
do
know,
the
I
light
like
blue.
that.
Do the light blue.
I can't.
There
That's
you
better.
go.
Is that the best?
Yeah, I think orange is the best.
That orange was
I
bad.
I did like the orange. It's different looking on my computer than it is looking on your board. So that's why you have to.
We're going to hear us arguing over which color is the best.
All right, so it says algebraically the y coordinate does not affect the value of dy dx in cosine x. Why not? Why isn't the y value or the c plus c affecting it?
Change the slope.
Because it doesn't change the slope, because the derivative would be, the derivative of the y value would be 0. The up and down does not affect the slope. Also, that plus c becomes 0 when you take dy dx. So I want you to think outside the box.
Can we write that on our test up and down?
Oh no.
Okay. Just figure that out.
No.
What about like your headache and your stomach?
It's just like I just like want to curl up
You
into
just,
a
like,
ball. Like I just like
I wouldn't.
But
Eat.
it's
my
just you don't
stomach just
feel right,
hurts.
yeah.
Yeah. Like I didn't eat dinner. I have not eaten since lunch yesterday. Yeah.
I know what you mean. Like there are certain times that like I can't tell which one. I just like don't feel right.
Yeah. I mean, my stomach definitely hurts.
But
like,
yeah.
I don't feel like I'm gonna throw up. I feel like I could throw up, but yet I have no desire to throw up.
Yeah.
That's like, have you ever like felt like you want to throw up so bad you like want to force yourself? Like I want to force myself to throw up right now. Like, that's
Anytime
how
I eat too much food, it's just you curl up in
But-
a ball, don't move, and
But this isn't because I ate too much. Like I didn't eat too much.
that's the only time I curl
That's
up.
the exact opposite.
Okay, does the graph show that the y-coordinate does not affect the value of dy dx? Yes, it does. That's what we talked about prior to me showing you this. All of the slopes are equal at every value of x, regardless of the y. One year I gave the kids those graphs and made them answer all these questions on their own.
Ooh.
Thank you for that.
I just wanted to see what they could come up with.
You can blank page back.
According to the differential equation dy dx equals cosine x, what should be the slope of the solution curves when x equals 0? Oh, really? I noticed it the minute I read it. All right. There was an I in the word curves. Like I had a typo. So according to the differential, what should be the slope of the solution curves when x equals 0? So go to your graph. When x is 0, what does that slope look to be? 1. That kind of makes sense, right? It's the unit sign, so the slope should be 1. How could you actually calculate that? Well, isn't dy dx represent the slope? So if you find the cosine of 0, do you not in fact get 1? So do you see how graphically and algebraically it's starting to make sense? Is the graph I gave you up top, is that cosine or sine? What graph is graphed?
Sine, because it's the derivative of cosine. Technically,
Exactly. The graph that is graphed is sine. You graphed sine, not cosine. So
Isn't the derivative of cosine negative sine?
antiderivative. Remember, the derivative of sine is cosine. The derivative of cosine, negative sine.
So isn't this negative sine? Solve the equation dy dx. So this here is the.
No.
Oh, you're taking the integral.
Yeah, the integral of cosine
Never mind.
is sine. I was like, you really had my brain like.
I had my brain confused.
Okay, according to the differential dy dx equals cosine x, what should the slope of the solution curves be when x equals pi? So again, go to pi on your graph.
0.
No.
Oh, -1.
Negative 1, because the graph is going down. What do you know about the cosine of pi? -1.
No, because this is the one.
Okay, cosine is an even function, therefore the slope at any point should be the same as the slope as its reflection. How can you tell? Well, if you plug in cosine of negative x, you get cosine x. Cosine of negative pi is equal to cosine pi. And if you look up at your previous example, that should make sense, because cosine of negative pi would take you back to pi if you think about your unit circle and adding 2 pi to it.
Whoa.
Oh, these are cool.
You're going to make one. So we could take the ideas explored above and use them to produce a graph for any differential equation. Since dy dx gives the slope, dy dx gives the slope. That's what your lines or tick marks represent. They represent dy dx. They represent the slope. At any point xy, we can use the information to draw small pieces of linearizations at that point. Repeating this process creates a slope field. So a slope field is the first order differential equation dy dx, where you have a plot of short line segments with slopes f of xy for a lattice of points xy on the plane. Horribly long, crazy definition. All it basically means is that you are going to pick a point xy. So if you look at like the previous example we just picked, you could have looked at the point 0, 1. So on the derivative at the point 0, 1, what was the slope? Well, dy dx at the cosine of 0 was 1. So then you would draw a line segment at 0, 1 that had a slope of 1. Does that make sense? A little bit?
Maybe.
So what's our equation for this problem?
This one here.
So basically on the one I just gave you, that equation there, let's say that that represents dy dx equals negative x divides y.
Isn't that the graph?
Oh, I can't.
Cosine?
No. This is the equation of a circle.
Okay, yeah, but that's gonna.
Think about it. Take its antiderivative.
No, that is a circle.
I know.
I thought I was looking at this. I thought we were continuing the idea from this.
So if you make a table for this, your table's set up a little bit different now. Your table is set up as an ordered pair and then a slope. So let's say, for example, I have the ordered pair 1, 0. So that represents, oh, that's a, well, it still works. It's actually a good one. At 1, 0, you get negative 1 divided by 0. What happens when you divide by 0? It becomes undefined. An undefined slope is actually a vertical tangent. Hence why the line at 1, 0 is straight up and down. So an undefined slope becomes a vertical asymptote or vertical tangent of the expression and will be a line straight up and down. Okay, let's pick 2, 2. That's negative 2 divided by 2. So your slope is, so you go to 2, 2. And if you look here, doesn't that kind of look like it's going down negative 1? All right. How about negative 3, negative 4? So you plug in negative 3, you get positive 3 divided by negative 4. So that means my slope should be negative 3/4. So if you go over here, 1, 2, 3, 1, 2, 3, 4, you could actually draw in a line with a slope of negative 3/4. So what would a line with a slope of negative 3/4 kind of look like? It's got to go down 3 over 4. So is it more steep or less steep? Okay. Why are all of the slopes on the y-axis 0?
Because it's all fine with 0.
Points out that x equals 0. It's always 0.
So no matter what you get, you're going to get a 0. A 0 is a horizontal tangent. So it's always going to look like this. A 0 represents an extrema, right? So what I want you to do is, we now know how to take the antiderivative of this. How do you take the antiderivative of dy dx equals negative x over y?
Multiple both sides by dx.
Okay, so you multiply both sides by dx.
And multiply both sides by y.
Yep.
Which will then leave you with y is equal to negative 1.
So this
That
is
was
one of the things I
opposite,
wanted to make note of, and I think, again, it stresses it a lot more in 6-1. A lot of you are not writing your dx's in. That would kill you on the AP exam. So, like, you've got to make sure you put your dx's, and you have got to make sure your integral follows. Or if it's bounded, you have to make sure you always write the bounds. If you're going to put equal signs, you have to make sure it's actually equal.
So it's y squared over 2 is equal to negative x squared over 2, which then gives you y squared plus x squared over 2 is equal to c.
Yep. So you get y squared over 2 equals negative x squared over 2 plus c. So what you could do is kind of in your head multiply both sides by 2 to even get rid of it. Add the x squared over, and you get y squared plus x squared equals c. The c doesn't show the 2 on it because it absorbs it, because it's constant. And again, what does this become?
Or the
It becomes
equation of
a circle. X squared plus y squared equals r squared. But the r squared is the c. So whatever your radius was would tell you where you go on the circle. So if your c value was 2, that means your radius is the square root of 2. If your c value is 4, then your radius is 2. And then you would draw in your circle at those points. So I said, I feel like this kind of culminates everything we've been doing. It makes derivatives connect to integrals, more than fundamental theorem. Okay? Plot the slope field for the differential dy dx equals 2y. What value or variable is unaffected by your slope?
dx.
Yeah.
Or
Or just your x value is unaffected. So what that means is that every x value for that particular y, the slope is going to be the same. For those x values at that particular y, the slope is going to be the same. That makes drawing your slope field rather easy, because the only thing affected by it is your y. So, make yourself your table. So I picked just the first kind of 5 general values of y.
Wait, why did we get rid of dx?
They just
when y
instead of,
equal- okay.
yeah, like this represents all the x values when y is 1. This represents all the x values when y is 2, because the x values are unaffected by the y value, or by the slope of this problem. So the slope, this is representing dy dx. So go over to your slope field, and remember the x value don't matter. The y values matter. So when the y values are 1, your slope is 2. So that means horizontally, when the y values are 1, all slopes are 2. So you're going to go and have the same slope horizontally at 2. So at all y values of 1, all of my slope lines are the same. At all y values of 2, all of my slopes are the same. And 2 is steeper than 1, so you can see these are kind of going up a little more.
Aren't they just 1/2 though?
They're 4. Slope is 4.
Oh, that's a word correct.
At 0, the slope is 0. Therefore, you have an asymptote there. At -1, -2, your slope is -2. So it's the inverse slope of these.
Don't grab that purple yet.
Ooh. So that's going to look like that, and then this is going to have.
So the purple says, suppose that this function goes through a given point 0, -1. So you plot your point at 0, -1. Your point follows the slope field lines. So this slope line here tells me my graph goes up. As my graph is going up, it's approaching a horizontal tangent line, therefore it's flatlining. As my graph is going down, the slopes are getting steeper, so my graph is getting steeper. What type of function or equation does this kind of look like?
I think a square root of something. Negative square root.
Let's find out. We can calculate it, right? We know how to take an antiderivative of any function now. I don't know if that's actually part of your questions.
Well, let's do it.
Oh, we're going. I'm sitting.
Example 8 part of example 7.
Yes. Yes. And then
Example 9 on the back is solve it
that's what I thought I did it.
by
Yeah.
separating
Yeah.
variables.
Yep. Example 9 is what I want you to do. So don't, unless you want to put it underneath all that, you have space, but example 9 is finding what we're talking about. I don't like the way I have it spaced.
Don't we have to figure out it's different because this would then give you dy is equal to something with the x, right?
Okay. So you know you need to group the y's with the y's, right?
Yeah.
And you got to get the dx's with the x's. Well, there's no x's in this problem. So you'd still multiply by dx on both sides,
And then divide by.
and then divide by, and you can choose to divide by 2y, or you can choose to divide by y. Now I personally would only divide by y.
Because that would just leave you with y equals. Or.
No, I'm going to leave you with that. What is the antiderivative of 1 over a variable? ln. Whereas if I put the 2 on there, then you have to account for the 2 in your antiderivative. So you get the natural log of y equals 2x plus c. How do I get rid of an ln on my y? E both sides.
2x plus c.
Now, if you think back to the rule,
It's a negative though, isn't it? Because it's flipped.
yeah, but you don't know what your constant is, and that's what we're going to talk about. Yes.
Does dy just become 1? Is that why it just kind of just wait, okay, wait.
dy became the ln of y. Because the derivative of natural log of y would be 1 over y. Derivative of ln y is 1 over y.
Okay. If you take the antiderivative of dy, wouldn't it just become y and the y would cancel out
But
the other
this
y?
has a y. But you can't take the antiderivative without this y being over here. You can't take the antiderivative of dy equals 2y dx. You can't take an antiderivative if your variables are mixed. It's just like taking a derivative. Like when I had you taking derivatives of like y squareds, you had to say that was 2y dy dx because it was the derivative of y with respect to x.
But does y dy become anything? Like, is it just 1, or does it? Like, if it did become y, wouldn't you still have wouldn't it be y ln of y, or something like that?
I feel like I kind of know where you're asking me, but the dy in the antiderivative is kind of like area. It's length times width. It represents the width, which is infinitesimally small. So dy is kind of like a 0.
So like you can
It
just
zeroes out.
ignore it.
Yeah, it's yeah.
Okay, I think that makes more sense. Alright, thank you.
So, when you think about exponentials or variables raised to powers in general, like if you had x to the 2m plus n, how did you get there?
What, bring it down?
So you got there because you took x to the 2m times x to the n, right? Or if you think about x squared times x squared, you tell me that that's equal to x to the 4th. But how do you get to x to the 4th? You say 2 plus 2, right? You add them. So here, this is like e to the 2x plus c. Well, that's really kind of like saying e to the 2x times e to the c. But e to the c is exactly that. It's a constant because e is a number raised to a power. So this then becomes c e to the 2x. So when you're solving for your c, you're solving for the constant, which would represent the... So think about your equations for an exponential. It was y equals y naught e. So like the kt in general, that's a formula you probably used in chem or physics, or because it was like a growth or decay, or it's a exactly, it's the decay of radiation. What does the y naught represent?
The rate of like the average.
Okay, let's go back to this.
Positive or negative.
How about P equals ERT? You did that one. PERT.
No idea
What?
what that is.
What?
Is that a physics thing?
No, that's an algebra 2 and trig thing. Like I
Potential
literally just
energy
tutored a kid in
times-
honors algebra 2 on this. What? You really have never used this equation?
I probably used it, but I don't remember. Yeah. What is it?
Direction, maybe?
How about,
Potential energy times rate times time.
no. How about y equals a, no, it would be a equals p 1 plus r over n.
That looks familiar.
What does the
that
P
does
stand
look.
for?
Exactly, what does the p stand
That's a
for?
good
Is that the
It's
period?
constant.
No, that's the period.
No,
right?
you have one in this building.
Physical idea.
Period.
Principle.
What? What?
I have no idea what that is.
The principle. So this equation here and this equation here,
Are you sure this is
Rep-
not?
yeah, this represents compound interest. So it represents if you put money in
is
a
that
bank
interest?
account at an interest rate,
Is that the original? Like the principles? Isn't that
the principle is exactly that. It is the original.
amount?
What's a mathy word for original?
Initial condition.
Initial. What's y not in physics
Oh,
represent?
that's original or
You're asking the
initial.
wrong word.
Initial.
Initial condition.
Okay, v naught. That's your starting
he uses
velocity.
he uses I, not O.
Well, it doesn't call it not or whatever he calls it.
I've
It's like
never heard
Y
of
about.
that term.
Yeah, and he goes VI is an FI. He has last year in 2 he did use YO a couple times. But he
So the
sticks
naught
to the-
that represent because the naught means 0. It means the y value at time 0. That's why it's a sub-zero. Like I doesn't make sense because I is like a complex. So this represents the initial. What does the C values we kind of find? They're always the
Initial.
condition. So this equation is really a variation of that.
Yeah, now that you say that, it looks more familiar, but
It really should. And I'm sure Mrs. Lacey would kill you all if she told her.
I remember PERT.
I
just don't
remember
what.
PERT.
I remember
just don't
PERT. I
remember,
didn't remember what it
yeah.
was used for exactly.
We did. literally in 1/6.
Yeah. Oh, that was
What?
that was such a long time ago.
Great. I guess I should be mad at you.
No. I say you give us the day off because of that mishap.
Give us time to
We have
make
like 10
music.
minutes left to get a day off.
Yeah, give us the entire day off.
All right.
Oh, that would be so nice.
Create a slope field for dy dx equals x minus 2y. So you have a 3 by 3 sort of triangle, rectangular field. So you pick your points, x, y, and then you pick your slope. So start with 0, 0. At 0, 0, your slope is
0.
So that represents a horizontal line. You don't need to plug it in or write it down. You don't have to. The table is to assist you. Okay? How about 1, 1? 1 minus 2 is
1, -1.
1.
negative 1. So a line with a slope of negative 1 will be down slightly.
Mm-hmm.
Okay, how about 2, 2?
-2.
So what's that mean about my slope?
Steeper.
More
Steeper. How about negative 1, negative 1?
+1. I'm assuming it's just this probably some type of circle or something.
How about negative 2, negative 2?
What kind of circles are you going?
I'm just looking.
So you get positive too.
Okay.
Oh, it's a cubic function.
How about
Yeah, probably wrong too.
negative 1, 0?
-1.
That's just, I said yeah.
I thought you said and I was like, what?
No, I said
Okay, how about 1, 0?
1.
No, I was gonna say that.
Yeah. It's like, I still have no idea what this graph is look like. It's like connect the dots. I don't know how to do it. I guess it's a lot harder.
1, negative 1?
Oh, I didn't expect that one. 1, -1. 3. This is a long table.
I don't know what this is supposed to look like.
What is this?
You could calculate it, you know. That'll whimpering.
Yeah, well, the variables are all screwed up.
Okay, 2, 0. All the ones with zeros are nice,
2.
right?
-2 is the next one.
She's gonna pick like
If you're gonna say
-2,
0.
3.
Huh?
That's not the. It's a different slope than 1. It looks the same.
Nah, that's definitely steeper.
Then 1. 1, 0.
-2. There you
That's not confusing now.
Coming from the kid that's not writing it down at all.
I'm
go. Hey, I'm actually writing it down for once.
because I'm just trying to make sense of this graph. Like, what is that? How do you make a line out of that?
Oh, what do you want to do now? We only have a couple ones left. What do you want to do?
Couple.
We'll do -1, 1. Zero.
What?
Zero.
-3.
One.
Hit.
-3. Whatever it is.
-3.
-1 minus 2 is -3.
What are you noticing about these slopes?
We're getting bigger.
Yeah, so what do you think is going to happen when I plug in this one?
-4.
So what do you think probably means you have here?
A 0.
Oh, so that means that -3, -1 is 0.
option.
Negative 2.
Yeah, negative 2.
1.
Okay, 1.
Negative 2, negative 1.
Yeah.
It's 0.
I understand. Yeah, I just like saying.
I didn't know. I really thought you meant way over here. I was like, what? Okay, so what's this one then?
2.
4.
4. 0.
So what are you noticing about this row and that
You don't even know
row?
what I'm talking about.
It just shifted.
They're opposites.
2.
Alright. What did you notice about these two?
No idea.
What are your corners? This is negative 2 and this is...
2.
So what do you think this slope's going to be?
Is it going to be like the
Negative
x-axis?
negative 1.
Okay, so if you actually plug in 1 minus 4,
Negative 3.
okay, so you went the wrong way. You went this way, went that way.
So negative 3, negative 4, negative 5, negative 6, and then 3, 4, 5, 6. Which is
How about the only one we skipped?
that's negative 2.
Negative 2. And where did that get us?
Well, what do you notice is happening in here?
That's a slope of 0.
It's a,
Yeah, they're asymptotes. So, when we
Yes, that's
connect our dots, this graph is going to have some asymptotic behavior.
Like a lot.
Sure.
No, it's only 1 because it's just
Yeah.
H times.
Is this a slant asymptote?
So this would become 2y
Oh, you're right.
equals x dx. It is a slant.
Whoa, what just happened?
I added 2y and multiplied by dx. I added 2y,
Uh-huh.
multiplied by dx.
Whoa, where's
Sorry.
the dy?
Sorry, I thought I wrote it in front. I'm out of space now. So if you add dy, right, or add 2y,
Yes, but the thing is, isn't it when you multiply both sides, that dx has to go to that 2y?
yes. So then doesn't that kind of mess this up for an antiderivative?
Yes.
Yeah. So what could we do?
Yes.
No, we can do that
It's to come.
the FTC.
Yes. You could do an FTC where you plug in an input and output in original.
Like
But
a
it
zero-
doesn't
do
ask you-
0x.
So that's what you have to figure. This just said construct a slope field. It didn't ask you for what it is. I just wanted you to see why it didn't work, and then I failed because I didn't even write my UI.
So much for the short lesson.
It's been half a period.
I know.